Now that we have a lot of the preliminaries out of the way, let's actually create a confidence interval. And this is actually going to be probably the easiest part. Remember the formula for this? The majority of the time is to familiarize yourself with the logic, how this works, and the ramifications. What is the proportion of students that would pass Math 60 using only ALEKS instructional software to instruct students? 5 classes are randomly selected to participate. Out of 157 students in the 5 courses, 110 passed. So let's notice one thing. Out of 157 students, 110 passed. Do I need to see successes? And again, what is success here? What is the proportion of students that would pass? Okay, so passing Math 60 is success. In this case, out of 157 students, 110 passed. So I have 110 successes. Notice that's bigger than test. Failures. Well, the rest of them have to be failures. So subtract 10 from 57, that's 47. So I got 47 failures. So yes, notice meet CLT condition. Step 1 accomplished. Let's see, what else do we need? So our sample size is definitely large enough. Does this seem like it's unbiased? Well, you have 5 classes randomly selected to participate. Now, are those 5 classes representative? You know, if they're randomly selected, it can be, right? So I'm going to say, yeah, should be unbiased. And again, this is about passing for a class. So, and this is again a difficult part in that what exactly is a population. So we're not going to get into that, but that's the kind of questions you start to wondering. Is it the individual students? Is it the class? What is it exactly that we're focusing on? So I'm going to say it's fine. Use a confidence interval to estimate the proportion of students in the general population that would pass Math 60 using only ALEKS. So now what we're trying to figure out is what is P? And the answer is we'll never know exactly what that is. The next thing we need to determine is, well, what do we find? Let's do that first. P hat was 157, or whichever point estimate out of, nope, 110 out of 157. So this is our point estimate. Let's see, to get a kind of an idea, what is this? If I were to type it out, it's about 70.00637. Okay, that's our point estimate. Fantastic. Now, the next thing we really need is we need to determine a confidence level. The question doesn't tell us the confidence level, so I'm going to pick one. Let's choose confidence level, choose 95% confidence level. I'm going to call it C alpha confidence level. So because I did that, then Z star, as we saw earlier, is 1.960. So I get to choose my confidence level. It's nothing defined by the situation. It's user picked. Great. So now we're ready to figure this out. My formula just says use my point estimate plus or minus my critical value, which is really tied to the confidence level, followed by the standard error. And I'm going to break this up into little parts, not that I want to, but just to emphasize the parts. So let's say I calculate the standard error first. I'm going to come over here. What is the standard error? So it's square root of, and I'm going to click the fraction button. Notice I didn't click the square root button. I just typed SQRT to get that. And so in fact, when I hit it again, this is a complete, I'm going to put this the denominator so I won't lose track of where the denominator is, 157. But the numerator consists of 2 other fractions, 110, 157, and then 1 minus, again, the other fraction. 10, 1, 5, 7. Plus or minus, I know we get the, I'm going to leave this as a fraction here. 960, and this is times this value, 0.0365507, and I'm gonna just stop there. If you're in a piecemeal, what I call piecemeal, the one little part, you need to grab a lot. I grabbed 1, 2, 3, 4. It should be 8. 8 should be plenty. We'll reduce it down later anyway, so that should be plenty. But do not grab like 2. Then it's not going to come out right if you use something software like GeoGebra or MyOpenMath or whatever. If you grab 4, you're living dangerously. Just grab a bunch. And then what is that? So this is the standard error. This part. I'm going to just write it here. This is standard error is this one part up here, just this little part. What is the margin of error? Well, these two together, the product is a margin of error. So let me multiply that out now. I'll take the previous value times 1.96, and gives me this value right here. So this value is my margin of error. That should be plenty. 1, 2, 3, 4, 5, 6. So there is my margin of error. And as a reminder, what is the margin of error? Well, remember when we do this, it'll be p hat. And then when you add and subtract this part, that length you see right here is this number on either side. That's my margin of error. So this length is describing the margin of error. So you'll notice that wherever p hat landed, which is about 70%, I'm going to add subtract 7%. So within we are hopefully the parameter is within 7% approximately of where p hat landed. That's what we're saying. So now I'm going to add and subtract this value. Notice again, I'm grabbing lots of decimal places. I'm going to enter this fraction as is. Every time I just grab decimal places, I am approximating, but I'm grabbing so many that it should be fine. There you go. And so when I subtract, notice I get this. So I'm going to write using interval notation. And now I'm going to just approximate. I'm not going to write everything down. I don't need that much accuracy. I'm going to just go 4. If I go 4, it'll be 90. Right. And then all I need to do is come over here and just add that same amount. And again, I'm just going to do 4. And there's my confidence, my range estimate. So the confidence level. So this is a 95% confidence level. So what does that mean? And here is what we're about to say. And it has to be phrased this way, because otherwise this can get confusing. And here's a logic that a statistician would do. As a student, I didn't like it, but then I didn't quite understand that there's 2 types of probabilities at that time. There's one that is a personal probability and one that is a long run probability. The 95% that I chose for my confidence level is a long run probability. What does that mean? That means in the long run, 95% of our confidence intervals will contain the true parameter in the long run. Okay? But that's a long run. Now, a statistician says once you conduct this particular one, these particular 2 numbers, this is unique because this will change, and so will this. Grab another sample, these 2 numbers will change. So now that I've created this particular interval, the statistician logically would say, well, either this interval contains it or this interval does not contain it, which a student did not sit well with me. He goes, well, no, there's a 95% chance that this contains it. And the instructor would kindly say, no, actually that's false, because either it is or it isn't. It's already there. So after some explanation by the instructor, I finally understood that, remember, a probability is a long range thing. It's something is in the future. It hasn't happened. Once it happens, either it happened or it didn't happen. So there I'm kind of just thinking, scratching my head. Okay. But what I want to talk about is the chance of this containing, because yes, you're right. So instead, why don't you use a personal probability? Give me your belief that this particular interval with these two numbers contains the true parameter. And that's what I'm about to write next. So we don't say there's a 95% probability, for example, that this interval contains the true parameter, because the probability is in the future. It hasn't happened. We're not looking at something that has already happened. So instead, we'll use this phrase. That is the meaning of this interval. And what was the magic word that I was mentioning earlier? It's confident. We are 95% confident. The confident part means, so confident is some kind of keyword that implies personal probability. And what is a personal probability? Well, I'm a big baseball fan. Um, Somebody could walk up and go, what's the probability that your favorite baseball team this year can make it all the way to the World Series? And I go, well, gosh, looking at the situation, I have a 25% chance, I think, of making the World Series. That is my personal probability. It has nothing to do with long run, like flipping a coin and die. It's just my belief. So a personal probability is just based on your belief. Zero means there's no chance. So for example, if I answer the question, no, there's a zero chance, that means I have no belief that my team can make it. If I say 100%, I mean, I am 100%. I mean, my team will make the World Series, and everything else is just a feeling in between. But it's not a long run. This team is not going to play season after season after season, and in the long run, 25% of the time, they're going to get to the World Series. That's not what that means. It's just a one-time, you're feeling shot. Unlike a coin, there is then a long-run behavior. Or sampling. In that case, there is a long-run behavior. But here, no. In the personal probability, there's not. But again, it goes, isn't there a long-run behavior in this process? Absolutely. And that's what this 95% confidence level means. The process in the long run, 95% of the time, will create an interval that contains it. But when I get to a particular interval, then either this interval contains it or it does not. So now I have to fall back into a personal probability at that point. That's how this works. Now, do I believe this interval contains a true parameter? Well, there was a 95% chance in the long run that I would, right? Now, notice my language. I'm pushing this off into the future. I'm confident, 95% confidence level, that my interval would, hasn't happened, will, maybe would is past, okay, will contain the true parameter. So at that point, yeah, I'm up to believe it because of the process that I undertook. Okay, and that's the interpretation. We'll do one more.